All right, I think we can start. Hello, everybody. Thank you for coming to this talk. I hope you're in the right talk. There was a change in the schedule, which was totally my fault. This is what we're talking about here. So if you need to get up now and leave, I will not take it personally, but hopefully you're all in the right room. My name is Miro Cupak. I work at a Toronto-based company called DNA Stack, where we've built a cloud platform for genomics. But I'm here today to talk about Java, specifically type inference in Java. To give you some context for how this talk came to be, basically, when Java 10 came out, I was reading the chapters to see what's new in the release. And definitely the most visible thing there, and something that affects every Java developer, is the local variable type inference. That particular proposal is an interesting read, and I would definitely recommend checking it out. It basically explains where the local variable type inference is going to work, and it kind of hints at several edge cases where it's specifically not going to work by design. So while I was reading this, I couldn't help but think, why? Why does it work in this specific case? And why does it not work in this other case? And where exactly do you draw the line? Which specific cases does it actually work for? So I basically realized that I didn't have enough understanding of type inference in Java in general to be able to understand the whole set of constraints that is in place. The type system and the compiler in general were always just facilities that were just there for me to use, but I never really played around with them. I never really tried to pick them apart. But I've done some reading, and I've done that now. And in the next 40 minutes or so, I would like to share what I think is important to know about this topic. So we'll go over the evolution of type inference over several releases of Java, use that to explain sort of the basic terms that are featured in this space, and then we'll use that knowledge to set up various situations to test local variable type inference in, as it was introduced in Java 10 and then further extended in Java 11. Now, one thing you should know about me, I'm not very good at making slides. So I've prepared exactly 3 slides for you today. This is one of them, and this is another one. And as this slide suggests, the rest of this talk is going to be pretty much a live demo. I like learning for examples, so we'll go through a series of those, and we'll use them to kind of point out how type inference behaves in several different contexts. I'm going to write all these examples in JShell, which is a new feature we got in Java 9. So before we get to the main topic, let's take a brief look at JShell itself. So let me just switch to my terminal here. And I hope this is visible. I tried to sort of put it further up in the screen, and I hope the font is big enough. If not, please do complain. So what you're seeing here is JShell, which is Java's implementation of REPL, read, eval, print loop. So it's a tool that loops, continuously reads your input, evaluates it, and prints out the output. So it's very similar to interactive command line tools as you know them from other languages or technology stacks. Scala, Groovy, Python, they have all had that for a while. And finally, starting with Java 9, Java has an official REPL as well. REPL is really good when you're new to the language and you're just trying to learn Java, but it can be a very powerful tool for an experienced developer as well. It's very useful basically whenever you need to get something done very quickly. So it's useful for quickly trying something out, for prototyping, exploring new APIs. I've used it in interviews. It's also useful when you're switching technology stacks. You know, you've been working on this project in Python, now you're coming back to Java, and you need a reminder of how certain specific things work. So it's easy to just start JShell and try it out. It's very easy to figure out, as a tool like this should be. So rather than explaining this, let's just dive in and play around. Now, the main thing you need to know about JShell is that it supports 2 types of inputs. There's snippets, so the actual Java code that you want to evaluate, and there's commands to the actual JShell tool, which always start with a /. And we'll see a few of these throughout this talk. But let's start with something really simple. I'm just going to type 1 + 1. And you can see 2 interesting things here. First of all, 1 + 1 = 2. And second of all, 2 was assigned to something called $1 here. And $1 is an implicit variable that JShell created for me. And it does that whenever you have an expression that you don't assign to anything. I could have, of course, created my own variable, let's say x, and now I have an explicit named variable x. JShell has a couple of keyboard shortcuts. You've seen me use the first one here. Shift, Tab, and V introduces a new variable, and it infers the type of that variable from the expression. There's also a couple of syntactic shortcuts, sort of. For example, you've noticed that to evaluate the expression, I didn't need to wrap it in anything. I just typed 1 + 1 and got evaluated. I also don't need to use semicolons. For example, if I wanted to print this variable, I can just do something like this. And by the way, there's pretty standard tab completion as you would expect from any shell. And I can print this variable x. I also don't need to worry about catching exceptions, even checked exceptions. For example, if I wanted to put JShell to sleep for a bit, I can just call thread sleep. Let's say this actually throws interrupted exception, so that's checked exception. So let's say I'll just use 2 seconds, and this is going to work just fine. So this brings us to the first command, and the first command is Vars. Vars lists all the variables that I've declared. Similarly, there's methods and types. Obviously, I don't have any at this point, but let's actually try and write a few. So I will create a very small method. Shift-Tab-M helps you autocomplete a method. Let's call it increment, and it's going to take an integer and just return that integer +1. So I can test it out. Works just fine. Similarly, I can create a class. Let's create a simple one here, my class. And for simplicity, let's just give it a static method, void, let's say hello. And all this does is that actually print something to standard output. Let's say hello GeeCON. And now close everything. And since this is a static method, I can test it just like this and work just fine. Another really important command here is list. And list lists all the active snippets. By the way, JShell has this prefix matching going on, so as long as you specify a unique prefix of a command, it's going to find and execute it correctly. So I could have just done something like this. And finally, there is a command help, which tells you pretty much anything there is to know about JShell. It's actually really comprehensive. I would definitely recommend checking this out if you're playing around with the tool. And that's pretty much all that you need to know about JShell. So let's take a look at type inference. Type inference refers to compiler's ability to derive types where types are not specified. So basically deriving types from the surrounding context, right? So it's a pretty fundamental thing in a language and something that doesn't change very frequently. There have only been a few updates to the system in the history of Java. And the updates basically involve creating a new context where type inference works. So Java 5 was the first release that introduced us to type inference. And that was kind of a complementary feature to another really big feature in the release, which of course was generics. So generics and type inference kind of go hand in hand. Let's start by talking about generics a bit, and let's point out the basic terms there that are related to type inference. So since Java 5, we don't need to use raw types anymore. We can use parameterized types. So a very basic usage for generics could be something like this. Just create a list of strings, and let's make it a new array list. Just like this. And this is sort of generics 101. So we take a look at Java.doc of list here. You can see that it's defined like this. And this is what we call a generic type. And this E in the angle brackets here, this is what we call a type parameter. And in fact, if you look at Java.doc and we scroll further down, it's actually going to tell you that this is a type parameter. There are two types of type parameters. There are formal type parameters, which is the E here. And then there are actual type parameters, which is what the formal type parameters are replaced with for a particular invocation, right? So in our case, formal type parameter would be E, actual parameter would be string. Similarly, generic type would be list of E, parameterized type would be list of string. So these are sort of the basic terms there. One subtle but very important thing to note is that this list of string is not just an expansion where E was replaced by a string, right? So generics is not about taking this formal template and then creating copies for the individual types. It is a compile time thing, but every generic expression is only compiled once in a way that satisfies all these expressions. So let me see what I mean. I'll just create another array list of strings and then another one of integer. And if I take a look at the class of the first one and compare it to the class of the second one, it's going to say that they're equal, right? In fact, if we take a look at one of them, it's going to tell us that it's an array list. It's not an array list of string, it's not an array list of integer, it's just an array list. And this happens because of something called type erasure. Basically, to make sure that generics doesn't incur any runtime overhead, the compiler applies the process called type erasure, where it essentially erases anything that's generic. So a list of string gets converted to list. All the stuff in angle brackets essentially disappears. Similarly, all remaining uses of type variables are replaced by the upper bound, and we'll talk about upper bounds a bit later on. Usually, this would be an object. And whenever there's resulting code that's still not type safe, a cast will be added. So that way, we can keep the JVM type safe, and the bytecode only stores regular classes. So that leads to some interesting things. If I create a generic class, I can use its type parameter in instance methods and fields. In other words, if I create a class like this, let's say my class, and let's give it a parameter, and then I'll just use an attribute for simplicity. Let's do something like this. So this, of course, works. That's pretty basic usage of generics. You've seen this many times. I can create a new instance, let's say of string, and access the attribute. No problem there. Things change if I try to make this static. Now suddenly, this doesn't compile. And it doesn't compile because, remember, for generics, everything is only compiled once for everybody. So in other words, generic classes are shared by all the invocations, which also means that static variables and methods are shared as well. And that's why it's illegal to refer to type parameters in a static context. So we have generic classes, right? But we also have generic methods, which are methods that introduce their own type parameters. So they're very similar to generic types, but the type parameter is scoped to a method. And of course, you can have static, non-static methods, as well as generic constructors if you want to. So here's an example of a generic method. Let's say I want to have a method that adds an element to a collection. And I'm not happy with the default method that's in the collections API. I want my method to actually return the whole collection after the element is added. So what I can do here is create a simple wrapper method. Where I'll just say, OK, use this type parameter, return collection of t, and then let's call this method add. And the method add takes a collection t, let's call this items, and the actual item of the same type. And then let's add the item to our collection, and let's return the whole thing. And that's pretty much it. So let's try it out. Let's give it an array list of string, and a string like this, and this works. And if we take a look at the variables that we've created, we can see that this is actually correctly inferred as collection of strings. So how does the compiler know? Well, it infers this from the use of the method. It knows the type of the arguments, so it can tell, right? So that's another example of type inference as it works in Java 5. So one thing that I hinted at the beginning is that we can have bounded and unbounded type parameters. And what we've seen so far are, of course, unbounded, but I can also place explicit bounds and express things like this method only takes, a type and all its subtypes, which would be the upper bound, or a type and all its supertypes, which would be the lower bound. And we do this by using the keyword extends. So let me just drop this method here so that I can recreate it from scratch. And I can just modify it here so that it only works for, let's say, numbers, just like this. So now if I try to add a string, of course, this won't work. And if I try to add an integer, this will work just fine. And you can have multiple bounds as well. So I can do this, for example. I can say t extends number and comparable, for example. And now, of course, this still works. But this construct, this extends and then multiple types, is known as the intersection types. And this is something that only works with generics. You can't just declare something as something that has two interfaces. So this brings us to wildcards. Wildcards are represented by the question mark in Java, and they refer to an unknown type. And the basic use case is flexible subtyping. And we can use keywords extends and super to specify upper and lower bounds for wildcards as well. I just wanted to mention this because people sometimes confuse bounded type parameters with wildcards, but they're not the same thing. They are very similar in the sense that quite often we can express things both ways, but they're essentially different concepts. And they actually play very nice together. So to make my method more flexible, and actually let's take the basic one. I can just do something like this. Wildcard super t, same here. Effectively telling it, OK, accept collections of all the supertypes of my thing as well, because I know that I can always add my thing to a collection that contains the supertypes, right? So this will still work here. So wildcards and type parameters, not exclusive, and play very nice together. So this is Java 5 and the scope of type inference in Java 5. Another context was added in Java 7, and Java 7 added the diamond operator. So now instead of list string equals new array list string like this, we can just do this, right? I'm sure everybody knows this. But here, the compiler infers the type of the collection instantiated from the variable the collection is assigned to. In other words, it uses the expected assignment type to infer the type parameters of the constructor, right? So that's another very interesting context for type inference. So now we're getting into the modern days, Java 8. And Java 8 introduced something that's called the Generalized Target Type Inference. And basically, it introduced lambdas and streams, and it had to make modifications to type inference rules to better support these use cases. So as far as lambdas are concerned, they're actually a pretty interesting use case from the perspective of type inference, because they do not have an explicit type, right? So this is kind of the first situation where it feels like we don't need to specify a type at all, yet it somehow works. So here's an example of a simple lambda. I can use a functional interface, say consumer, and just say, okay, print this variable x. And this is a working lambda. And of course, I don't need to specify the type for x. It's inferred by looking at the target type of the context. As far as streams are concerned, Java 8 adds support for method target type inference in two contexts. There's argument position and chain calls for methods. And you don't even need to know what this means. Just by the sound of these words, you can probably tell that it's something that's very relevant for streams, right? So basically, what happens there is when we invoke a generic method without explicit type arguments, the compiler can look at the method invocation and the corresponding method declarations to determine the type arguments that make the invocation applicable. And this sounds really complicated, but it's actually very easy to explain. Let's take a look at this method, for example. There's a method called emptyList in the collections API, which, of course, creates an empty list. So by default, if we take a look here, it creates a list of objects. But of course, if we give it a better variable, let's say list string, it's going to create a list of strings, right? So this is standard stuff. This is nothing specific to Java 8. This was working before as well. What didn't work prior to Java 8 was type inference where generic methods like this occurred outside of the context of a direct assignment. So for example, when we were passing this to a method, I can create a very simple method here that takes an argument of list strings. Let's say a method print. It takes a list of string, and all it does, it actually prints that list. Just like this. And now what I can do is actually call print with my collections empty list, and this is going to work. So this only works since Java 8. Prior to Java 8, I would have to do something like this. I would have to explicitly tell the compiler that this is a string. Otherwise, it would complain that I'm trying to shove objects into something that's not meant to be an object. So it didn't see that extra level. But now it's able to look at what the method print expects. It sees it's the list of strings, and then it looks at the empty list. It sees it has formal parameter, so it correctly infers it as a string. So that's a pretty sophisticated level of inference. So that's Java 8. What's new in Java 9, right? Java 9 added a very simple extension. It extended the use of the diamond operator. The diamond operator is something we could use in pretty much everywhere except for anonymous classes. So it was kind of almost an inconsistency. But now we can actually do that too. So I can create a simple anonymous class. Let's say a supplier of string. Let's call it hello supplier. And this will be a new supplier of string. And we need to override a single method, which is public string get. And let's just tell it to return a fixed string. Hello GeeCON, and wrap everything. And now just to test it out, yes, this indeed works. So you can see that this works, but the type had to be specified on both sides. But starting with Java 9, we can actually just do this and basically use the diamond operator as we would do everywhere else. So that's a nice kind of little thing. So finally, this brings us to Java 10 and 11 and their local variable type inference, right? As is typical with Java features, this is not a new revolutionary concept, right? That Java tends to be very conservative when it comes to adoption of new features. And this is something that has been available in other languages for a very long time. In fact, what Java 10 adds is a very limited form of type inference. It basically only looks on the right side of a declaration, and it gives a variable a type of its initializer expression. So it's limited by design so that the functionality is not abused. And the goal with this feature was really to improve the developer experience by reducing boilerplate. So in Java 10, what we can do, we can declare local variables using the keyword var. Well, it's actually not a keyword. It's something called a reserved type name, and we'll see what that means later. So anyway, here's an example. Instead of doing this, I can now do this. And if we take a look at this variable, it's correctly inferred as an int. So if you're seeing this for the first time, you're probably thinking, this is a bit sketchy, right? There's probably some case of polymorphism where I can't infer the type because it's too complicated. And that's actually right, which is where there are very specific rules when you can do this. So let's examine this. And let's do this as a quiz, okay? I will give you exactly 33 very short code examples, sort of rapid-fire questions. And for each one of them, I will ask you a yes-no question. It will mostly be of the form, will this compile, right? And I will ask you to raise your hand if you think the answer is yes, and raise your hand if the answer is no. And we will see how well you do as the audience. So obviously, this is a new feature, so this isn't really testing your Java knowledge as much as it's testing your Java intuition for the type system, but I think it can still be fun. And I will also encourage you to write down whenever you get a question right, so that at the end, we can do a poll and see how well you did compared to other people in the audience. Okay? So ready? 33 questions. So let's start with generics. That's right, we're diving right in. So our favorite, very simple example, I'll just create a new array list of string, just like this. Who thinks this will compile? Okay, I don't think I'm going to have to ask the other option. It was pretty overwhelmingly yes. And of course, this will compile. And in fact, this is basically what the feature was designed for. Because things can get quite hard to read when you're dealing with generics. You can easily imagine that you have something like a map of objects to a list of other objects. So the type can get pretty complex. And with var, it improves readability significantly. One thing to note here is that if we take a look at this list, you can see that it was correctly inferred as an array list of string. But this is different from what you would normally do, right? Normally, you would code to the interface. So you would make this a list, not an array list. But here, when we're inferring, we're always inferring the most specific thing. So just be careful about this. Don't just automatically refactor everything to var because it's nicer to read when you upgrade to Java 10, because it can actually potentially break your code. Like in this case, if you try to assign a different implementation of a list, like a linked list, to the same variable somewhere further down in your code, it would work prior to Java 10, but when you change it to var, suddenly this wouldn't be a list, it would be just an array list, so it will break, right? So just something to keep in mind. This actually shouldn't affect you too much. Local variable type inference was designed for variables with very limited scope, so it doesn't happen very often that you would reassign a different type into a variable where you actually use var. But yeah, something to think about. Okay, question 2, declarations without explicit initialization. In other words, we know that this works. The question is this going to work? Who thinks this will work? Who thinks this will not work? Okay, I would say it's about 90-10 for no. And you are right, this will actually not work. It was basically a design decision to reject this kind of variables on the account of not knowing what the actual type was intended to be. So we're kind of trying to avoid this actions at distance error. So okay, in this case, it's complaining that it's not initialized. So how about we do initialize it, but give it a null? Who thinks this will compile? Okay, who thinks this will not compile? All right, it's probably 80-20 for no. And yeah, you're right, we did not trick it. This is basically the same example as before. It's saying it's still null, so probably it's still meant to be initialized later, and we don't know what the type will be, right? So okay, since the argument for this is we don't know what the type will be, what if I explicitly tell it that this is an integer null? Who thinks this will compile? Okay, who thinks this will not compile? All right, probably 90-10 for yes. And you're right, this will actually compile. So this was really the only problem. We just need to tell it what we want. Question 5, compound declarations. We all know we can initialize multiple variables on a single line. It's not exactly recommended from the perspective of writing clean code, but it does work. So how about we make this a var? Who thinks this will compile? Who thinks this will not compile? Okay, so it's almost 100% for a yes, but this actually does not work. And that was just, again, kind of a design decision. It was deemed too confusing, so they basically prohibited this from working. All right, how about method signatures? So I had the method increment here, so let's just recreate it very quickly. Something like this, and then just return x plus 1. And this is fine. So now let's change this argument here to use var. Who thinks this will work? Who thinks this will not work? Okay, overwhelmingly a no. And you're right, var is not allowed for arguments of the methods. Okay, fair enough, so it doesn't work with an argument. How about the return type? Who thinks this will work? Who thinks this will not work? Okay, about 80-20 split, I would say. No, still doesn't work. Basically, var is not allowed anywhere in the method signature. Okay, how about for loops then? How about I create a for loop, something like this. Let's say 0, less than 100. And let's just do an empty for loop. Who thinks this will work? Who thinks this will not work? Okay, overwhelmingly yes. And indeed, it does work. And not only it does work, this was actually something that this feature was particularly designed for. So this is a standard for loop. How about the for each? How about I do something like this? Who thinks this will work? Who thinks this will not work? Okay, maybe 70-30 for yes. Yeah, again, something the feature was designed for. There's no reason why this shouldn't work. All right, question 10, primitive types. Of course, we can do something like this in Java, right? But how about I replace this with var here? Who thinks this will work? Who thinks this will not work? That's interesting, because we've just seen that example. You saw it working, so there shouldn't be any confusion. This really does work. But if we take a look at this x, it's actually inferred as int. So I just wanted to point out that with primitive types, sometimes they don't infer to what you would expect them to infer. Many of them default to int. So just something to keep in mind. In principle, local variable type inference works, but just be careful about using this. All right. How about constructors now? I'll just create a simple class here. And let's just do this. Sorry, I wanted to use a constructor, right? So let's do the constructor first. So I will just use var as an argument for the constructor, something like this. Who thinks this works? Very good, nobody, because we've seen it doesn't work with methods, so there's no reason why it should work with constructors, right? How about fields? Going to remove this constructor here, and I will just add the field, properly initialize, just like this. Who thinks this is okay? Who thinks this is not okay? All right, probably 50-50. This is actually not okay. Var is not allowed there. Basically, it was just meant for variables with very limited scope, so they decided not to allow it at the class level. That's pretty much what it comes down to. Okay, so how about naming things? Obviously, now we have this new identifier in code that's called var. So a very natural question is, does this work? Can we name a variable var, right? So who thinks this will work? Who thinks this will not work? Okay, probably 50-50. Yeah, this does work. And this was actually a design goal. Basically, they tried not to break, as much code as they can possibly afford to. And this is why it's important that var is not a keyword, but it's a reserved type name. If it was a keyword, this would not work. So we know we can name variables var, right? How about methods? How about I do this? Who thinks this will work? Who thinks this will not work? Okay, overwhelmingly yes, and you are correct. It's basically the same as with variables. It does work. How about classes? How about I create a class named var, just something like this? Who thinks this will work? Who thinks this will not work? Okay, probably 60-40 for yes. No, this actually does not work. Var is not allowed there, and it even tells you that, you know, prior to Java 10, this would work. It doesn't work anymore, so it is a breaking change in that sense. But basically, the authors of this feature just concluded that this is so rare that you would use this because it breaks so many naming conventions that it's just kind of an acceptable loss. Okay, so it doesn't work with classes. How about interfaces? Who thinks this will work? Nobody. Pretty clear. Didn't trick you there. It doesn't work with classes. Of course, doesn't work with interfaces either. All right. We're halfway through question 17. Arrays. Okay. So let's try using var for elements of an array. In other words, let's do something like this. Who thinks this will work? Who thinks this will not work? Okay, about, I would say, 80-20 for this is working, whereas it's actually not working. And you can see here, var is not allowed as an element of an array. All right, not allowed as an element of the array. How about we infer the whole array? How about this? Who thinks this will work? Who thinks this will not work? Okay, about 90-10 for this working, but no, not allowed either, unfortunately. Okay, so how about we do the same thing, but we initialize it differently, just like this. Who thinks this will change thing and this will start working? Okay, who thinks this will not work? Okay, overwhelming yes, and this indeed does fix the problem. So if you look at the error message from the previous case, it actually tells you that array initializer needs an explicit target type, which is exactly what we've provided here. So yeah, that's how you should initialize arrays with var. All right, question 20. How about we use this in the try block? In other words, how about I do something like this, create a variable, properly initialize it, then I'll just add a catch block. Let's say like this. Who thinks this will work? Who thinks this will not work? Okay, overwhelming yes, and it does indeed work. And I'm sure you can guess what my next question is. We tried it with try, how about we've tried with catch? How about this? Who thinks this will work? Very few people, so it's going to be an overwhelming no. And indeed, it does not work on catch. Basically, you want to be very specific what kind of exception you're catching. Okay, how about lambdas now? Let me just create a simple lambda here. Let's just do something like this. This is a very simple supplier. This obviously works. How about we replace it with var? Who thinks this will work? Who thinks this will not work? Okay, probably 60-40 for no. And yeah, this actually does not work. Lambda expression needs an explicit target type. And our initializer has no target type because we haven't inferred it yet. So this almost by definition cannot work. All right, so that's kind of whole lambda expressions. How about we use this for parameters in lambdas? Let's create a new lambda, let's say consumer, and let's just do something like this. So this works. Now let's add an explicit type, but use var. Who thinks this will work? Okay, who thinks this will not work? It's about 90-10 for no, but this actually works just fine. It is a tricky thing though. It is interesting because it only works because I'm running Java 11. If I was running Java 10, this would actually not work. This is a new extension that was added in Java 11. And it's basically a convenience thing. It just makes sense that it will work here. We could use it with local variables anyway, so why not Lambdas? It actually makes a few things easier. We can now add modifiers and annotations for Lambdas, so that's a nice little feature there. Sorry, what was that? Oh, it's a consumer. So if you want to see the detail, it just says consumer. Anyway, okay, we have a single Lambda parameter. How about we use multiple? How about I make this a by consumer and use X and Y? I'm just going to ignore Y. You know, doesn't matter if I actually do something with it. Let's just focus on the parameters. Who thinks this will work? Who thinks this will not work? Okay, about 90-10. But yeah, it does work. It's pretty much the same as the previous example. What I was kind of building towards, what if we start mixing var with, you know, standard Lambda stuff? In other words, what if I specify var for one of the variables and then just use the implicit type for the other? Who thinks this will work? Who thinks this will not work? Okay, probably 70-30 for not working. And you are correct, as it tells you, you cannot mix var with implicitly typed parameters. Fair enough. The obvious thing, how about explicitly typed parameters, right? If it tells you that it specifically doesn't work with implicit ones, how about we try this? Who thinks this will work? Who thinks this will not work? Okay, overwhelming yes, almost everybody. Yet, doesn't work. And here we see you cannot mix var with explicitly typed parameters either. So, unfortunately, didn't work. All right, Lambdas. How about method references? How about we change our consumer and just use a method reference here? So this works. How about this? Who thinks this will work? Who thinks this will not work? Okay, probably 90-10 for no. And indeed, this does not work. Lambda expressions need an explicit target type. So it's basically the same as Lambdas, right? It didn't work for Lambdas, so it cannot work for method references. All right, getting there. Question 28, diamond operator. So we've seen the basic generic use, right? Let's just do the same thing, but I'm not even going to give it a type in the array list. I'm just going to use the diamond. Who thinks this will work? Who thinks this will not work? Okay, everybody thinks this will not work. It does actually work. But if we take a look at this list here, it's an array list of object, which is almost never what you actually want, right? So basically, the diamond can use the target type. It can also use the constructor arguments. And if nothing is present, it defaults to object, which is what happens here. So it is an explicit initializer. So by definition, local variable type inference does work, but it probably leads to something that's not very useful. So now how about I change this and I pre-initialize this list into something that's of specific type, let's say an integer. So the question now is not if it's going to compile. We know this will compile. The question is this going to be inferred correctly now? Is this going to say that this is an array list of int? Who thinks it will? Who thinks it won't? Okay, probably 70-30 for no. And if we take a look here, yeah, this works just fine. All right. So how about we do this? How about we just use the raw type, not even use the diamond at all? Who thinks this will work? Who thinks this will not work? Okay, probably 80-20 for this will work. And yeah, it does work. If we take a look here, it's just the raw type. Sure, why not? All right, last three questions. Capture variables and types with nested capture variables. So we've seen capturing work with wildcards, right? So let's try to incorporate local variable type inference into this. Wildcards are kind of the easiest way to create capture variables. So let's start by creating a simple list of integers. Let's just call it a list. Obviously, this is a list of integers. We can extract an element from this. obviously, this element is going to be an integer, right? Nothing stinky happening here so far. But now, I'll create a list of unknown, called list2, and give it all the elements from my original list, right? So now, if we take a look at this second list, it is actually a list of unknown. So far, nothing happening behind the scenes. Now, I'm going to extract the element from the second list. Actually, I already have the command here. So let's just do this. And how about I try to immediately add it back to this list? How about something like this? Who thinks this will work? Okay, who thinks this won't work? Okay, I guess many people can tell that I'm kind of setting you up. It's probably 70-30 for this not working. And this indeed does not work. And the reason this doesn't work is because there's a special rule where capture variables are projected to supertypes that do not mention capture variables. In other words, capture variables are replaced with their upper bounds, which in many cases is just an object. So that's what happened here. If we take a look at the element that we extracted, this is where the problem happens, right? This is an object. So we extracted something from a list of unknown, and this is an object. And then, of course, we have a problem when we try to insert it back to a list of unknowns because it's an object. It's not, whatever is in that list. So, yeah, something to pay attention to, I guess. All right, last two questions. Anonymous classes. So, one thing that's kind of known about Java, and that probably many of you have hit at some point, is that it decided not to have a class for a pair or a tuple, right? So let's just create one on our own. And the simplest way to create this is, of course, by using an anonymous class. So I'll just create an object and give it a couple of attributes. Let's say A is 1. Let's say another attribute, B is 2. Just something like this. And let's call this X. So we have an anonymous class that represents a pair, right? Now the question is this going to work? Can I access the attribute? Who thinks this will work? Who thinks this will not work? Okay, pretty resounding no. But this actually does work. So yeah, you can access the elements, and it's a very simple implementation of an anonymous class. No big deal, right? Well, it actually kind of is a big deal. Because this is a pretty nice and a very concise implementation of a tuple, but I bet you've never seen this in code. And there is a reason why you've never seen this before. And that's because before Java 10, this actually wouldn't work. So if we take a look at the type of X here, it's actually something really weird. It's an anonymous class extending object, which is not something that we can declare directly, right? So basically, like capture variables, anonymous classes belong to so-called non-denotable types, which essentially means that you can't name them even when you're declaring them. So it's something that's supported by the compiler, and var kind of exposes it to you as well. So before Java 10, before var, I would have to name this class when I'm declaring it, and basically the only option that I have here is to make it an object, right? There's nothing more specific with a name. And if I make it an object, then obviously I cannot access the attribute, because this is just an object, and an object doesn't have an attribute called A, right? So this makes sense, and this is why I've never seen a tuple implemented as an anonymous class. And this is a big deal, because this shows that var is not just a syntactic shortcut, but can actually change the semantics of your programs, right? It's a good property to take advantage of, but I wouldn't probably recommend doing something exactly like this in your code, because it's not exactly readable, right? Person reading the code would have to know this specific trick. So basically, be careful when you're using this with anonymous classes. It not only enables additional functionality, like we've just seen, but it can also break your code. For example, if you were relying on this being an object, and later you would assign some other object into this, obviously you would have a problem now, because now it's not actually an object. All right, final question. Made it to the end. Intersection types, okay? So we talked about intersection types earlier when we were talking about bounded time parameters.
You can assign another object to this X? Probably not, because the type will be different.
Yes, that's exactly the issue. So let's say I'm in Java 9 and I have an object, I use an anonymous class, then I assign some other object into this, everything works. Then I upgrade to Java 10 and I change my object to use var, and then that other call would break because I'm trying to shove an object into something that's less than an object, more restrictive than an object, right? So yeah, that is correct. So yeah, intersection types. So I mentioned earlier that it only works with generics, right? So I can't create them directly. So I'll need to create the method to generate an intersection type. So let's create a simple generic method here. I'll just say, let's use the intersection type of number and let's say comparable. Comparable. And return this type. Let's call this method make intersection type. And let's keep it really simple. Let's just return null. So all I'm doing here is casting null to the special intersection type that I have here. So the question now is this going to work? Who thinks this will work? Who thinks this will not work? Okay, probably 60-40 for no. This does work, actually. And if I take a look at this type, it is indeed that intersection type. It is exactly number and comparable, which again is something that I cannot declare directly. So it's basically the same situation we had with anonymous classes. This also is a non-denotable type. So in this case, var exposes something more that we can do with this. All right, and that's the end of the quiz. So let's see how well you did. So 33 questions. Who got more than 10 correct? Okay, probably half the people. How about 15 or more? Quite a few. 20 or more? All right. How about 25 or more? Still a few people. That's actually incredible. How about 30 or more? Okay, 28 or more? Really? All right. 29? Okay, so 2 people got 29. Congratulations. Very good job. That is actually incredibly impressive. All right, so that's it from me. Since I don't really have any slides, what I can do here is actually save the history of this session into a file, and I can post this to Twitter or somewhere in case you want to get back to these examples. But otherwise, thank you. If you have any questions, we're pretty much out of time, but I'll be around, so come down and say hi, and enjoy the rest of the conference.